Good evening. Okay, good evening. Good evening. Very good evening. Let's start. So, where did we stop in the last class? I guess we were talking about thread programming. Good evening. Good evening. Right? So, in the last class, we were going through thread lifecycle. We saw various states of a thread, and we were going through how to create a user-defined thread using runnable interface. And today, I'll talk about synchronizing the threads. So, we saw an issue in the last class. Yeah. See, um, when multiple threads are operating on the same object, when multiple threads are operating on the same object, what will be the issues? I said we'll have overlapping issues. We'll have overlapping issues. So we saw that. You see, account was overdrawn. Account was not supposed to be overdrawn, but it got overdrawn. Why? So let me just run this code once quickly. See, you'll find that the account is overdrawn. We don't want this to happen. So what to do? Now, I explained the problem yesterday because both the threads are working on this object parallelly, right? And how these threads are working on this object parallelly, how these threads are operating on this object parallelly, can you people tell me? How the threads are operating on that object? What you understood? Yes. How the threads are operating on that object? Yes. So basically, the threads are operating on the object through this withdraw method. In the withdraw method, we have the instructions for the thread. Okay. Here we have the instructions for the thread. You see, whatever the instructions which we write in any method, threads are executing them. Now, in this method, we are instructing the thread to operate on that object. You see, we are asking the thread to read the balance, update the balance. These are all the things which are doing here. You got the point, all of you? Through the methods, the threads are operating on this object. Am I right? Yes. Do you agree? You got this point, all of you? Yeah. Through the methods. Through the methods. Right? So, here, now how do we address this issue which you got here? So both the methods are operating on this, both the threads are operating on this object through this method. But because they are executing parallelly, we have this issue. Yes. What to do? Any idea? No? Okay. Don't worry. I'll explain it. So here, you know what? You can simply declare this method as synchronized. Simply, simply declare this method as synchronized here. That's it. What happens in this result? You see, if a method is declared as synchronized, what happens? Okay, first of all, the issue is addressed. You will find that that account will not be overdrawn. Let's see. The account is not overdrawn this time. Yes. So how it works, I'll tell you. So there is something special about the synchronized keyword here. Okay. So this method, the methods which are declared as synchronized, you will find that a thread can only execute the synchronized methods. A thread can only execute the synchronized methods if they have an object lock. Any thread, if it wants to execute a synchronized method, it needs an object lock on that method. It needs object lock. Yes. Okay. So here, object lock of which class, sorry, object lock means which object here. You see, the thread is operating on which object through this method. This method belongs to which object? Savings account object. Okay, this thread basically it belongs to savings account object. So it is supposed to execute the. It is supposed to acquire a savings account object lock in order to execute this method. Okay, it is supposed to acquire savings account object lock in order to execute this method here. For an object, there will be only one lock. There will be just one lock. The thread has to acquire that lock in order to execute this method. Okay. So now for suppose we have two threads, right? Let's say if one of the thread, let's say thread 1 has acquired the object lock. Thread 1 has acquired the object lock. So, and it is executing this withdraw method. So when it acquires the object lock, then only it gets the right or a permission to execute this withdraw method. So now the other method, sorry, the other thread 2, meanwhile, let's say it also became active when it wants to execute this withdraw method. Will it be able to execute this withdraw method? I can say no, definitely. It cannot. Why? Because you see, thread 1 has already acquired the object lock. Now the object lock is with thread 1. So thread 1 thread is currently executing. It will retain this object lock till it is done with the execution of this method. So what the thread 2 is supposed to do, it has to wait for that object lock. It has to wait for the thread 1 to finish execution and release that object lock. Then only thread 2 will be able to acquire that object lock and execute this withdraw method. So both the threads cannot operate on this object at a time now. Okay. Yes. Fine. So that is what happens. So now you understood the meaning of synchronized method. What is the meaning of synchronized method? Any thread which wants to execute the synchronized method, it is supposed to acquire the object lock. Okay. So if it acquires the object lock, then only it will be able to execute the synchronized method. Otherwise, it cannot. It won't be able to execute the synchronized method. Yeah. Yeah. Is it clear? Can I have yes, please? Okay. My goodness. So fine. I hope everyone got it. So I hope you don't have any bandwidth consumption problems. If you're chatting, it won't consume your bandwidth. Okay. You can just type in messages. Uh, so it won't cost you anything. Please do that. I hope you people got it right. I hope everyone is available and you got this point. What we have discussed. I got only one response. There are five people here, right? Just got one response. So please, all of you, I hope this is clear, right? The problem is the issue with online training is that we can't see you people by looking at it. If it is a classroom training, what happens? You people will sit in front of me and I can see your faces. I can see your expressions in your face and understand whether you're able to understand the concepts or not, right? Yeah, that is not possible here. That's the problem. Okay, so now let's move on. All of you, I want you people to interact here. This is a very important point or topic which we're discussing now. Now, you see, the thread 1, if it is executing this withdraw method, synchronized withdraw method, thread 1 is executing synchronized withdraw method. Thread 2, will it be able to execute this withdraw method which is not synchronized? Other thread, thread 2, will it be able to execute this synchronized withdraw method?
No, sir.
No. What will be the problem?
Only one method execute at a time.
But the second method is not synchronized, right? Definitely it can execute it. The second withdraw method which we are talking about, it's not synchronized. Definitely you will be able to execute this method. There won't be any issues in this regard. Okay. So it can do that. That means, can I say that still the overlapping issue is addressed here? Yes. Think. It's very important. So I'm asking you people these questions there which are very important to make you people understand how the threads work. Let's see. One of the thread is operating on that object using the synchronized method, right? Now the other thread, will it be able to execute this withdraw method? The other thread, will it be able to execute this withdraw method? Yes, it can, because this second method is not synchronized. Okay, so any thread is free to execute this method. So that means now the second thread still can operate on that object through this withdraw method. So do you think that overlapping issues addressed here? Do you think overlapping issues addressed here? I can say no. Still we'll have that overlapping issue. Okay. Yes. Still have that issues. So what to do? You know, in this case, you have to also declare this method as synchronized. Not only this method, but any method which allows the threads to operate on that object, which allows the threads to modify that object state. You see, even the deposit method, you have to declare it as synchronized. Okay. Print details. Is it needed to make this method synchronized? What do you people think?
No, sir.
No. Why no?
No business logic.
Not business logic, but you see, we don't have any code to modify the state of this object. Here, we are not, through this method, we are just reading the state, but we are not updating or modifying the state of that object, right? So, it need not be synchronized. It won't affect in any ways. So, is pin valid? This method, is it supposed to be synchronized? Not needed. Okay, other methods also not needed. You see, now I can say that this object is thread safe. if you people remember, we did discuss about thread safe objects, right? So basically, what is a thread safe object?
All the methods have a synchronized keyword.
Mm, if all the methods are synchronized, you can say it is a thread safe object. So not exactly. You see, yeah, that is fine. Thread safe object means we did discuss about it. The object, you see, at any given point of time, if only one thread can operate on that object, then we say that object is a thread safe object. At any given point of time, only one thread will be able to operate on that object. If that is the case, we can say that object is a thread safe object. Okay, you can say that object is a thread safe object here. Yes, I hope you people got it. Yes, you know, here this savings account object is now thread safe because we have made sure that all the methods which operate the state of this object, they are declared as synchronized. Yes. Okay. So now I have a question for you people. Think about it carefully. We have two threads. Thread 1 is operating on savings account 1 object. We have a savings account object. Thread 2 is operating on savings account 2 object here. We have two different objects. You know, now you see these two threads are operating on two different objects. Let's say thread 1 is executing the synchronized withdraw method. Thread 1 is executing the synchronized withdraw method. Okay. In that case, thread 2, will it be allowed to execute that execute the synchronized withdraw method here? Yes. Thread 2, will it be allowed to execute the synchronized withdraw method? Yes, what do people think?
Can you please repeat the question?
If thread 1 is operating on the synchronized withdraw method, thread 2 will it be able to execute this withdraw method, synchronized withdraw method?
No, sir. Only one thread will execute at a time.
Okay,
If thread 1 will execute, thread 2 will not.
okay,
If thread 2 will execute on that method, thread 1 will not execute.
okay. That is what I one answer which I got here. So, what about others? What do people think? No idea. Okay. You know what? Thread 2 will be able to execute this withdraw method. Thread 2 will be able to execute this withdraw method. Why? Because thread 2 is operating on a different object. As I told you people, you see clearly, you saw this here. You will find that thread 2 definitely it can operate on that withdraw method here. Okay. I hope you people got this. Because they are operating on two different objects. There won't be any issue. Thread 1 has acquired the object lock of savings account 1 object. Thread 2, if it can obtain the object lock of that second account object, then of course it can execute it. What's the problem in that? There is no issue in that regard. Okay. So I hope you people got it. So this is what you need to understand regarding the synchronized methods. Now here, you see, always a thread in order to execute a synchronized method, it needs object lock. It needs object. Definitely, it needs object lock. Listen. So let's move on. You know what? Here, even static methods can be declared as synchronized. Yes, you can declare static methods as synchronized here. You can do that. What if a static method is declared as synchronized here? Yes, you know, a thread, in order to execute this static synchronized method, it needs an object lock. it needs an object lock, I can say. It's object lock. Sorry, class lock, not object lock. Thread, in order to execute non-static synchronized methods, it needs object lock. If a thread wants to execute a static synchronized method, it needs a class lock. Okay. Similar to object locks, you'll have class locks. Okay. Yes. See, let me just give you some notes on this. Synchronized, non-static, synchronized method. You see, a thread, in order to execute a non-static synchronized method, it needs object lock. Okay. Yes. At any given point of time, only one thread can acquire an object lock. Multiple threads cannot acquire an object lock. Okay. Yes. Okay. Yes. You have to remember this point. Next, we have static synchronized methods. Here, a thread, in order to execute, a static synchronized method, it needs a class lock. Okay. Even the same is the story for the class lock also. There is only one lock for a class. You see, for a class you can have n number of objects. For each object there will be one object lock. But you see, for a class, you will have one class lock. That's it. Okay. So synchronized methods. Yeah. So anyone got any issues in this regard, please let me know. I hope no one is talking to me, right? Okay, fine. So actually, I can say that there is one issue with object lock, synchronized methods. I can say we got one issue with synchronized methods. What do you people think? What is it? What is the issue with synchronized methods? Okay, how it can be a problem, Harsha? Yeah, actually, I can say that yes, it will affect the performance of the application because you see, at any given point of time, only one thread can operate on that object, right? Yes, that means the threads have to execute uh, serially, one after the other. So that's the reason why we say that performance hit is the major issue with synchronized methods, performance problems. So how can we issue this? How can we address this performance issue? Think about it. Give me 1 minute, please. Just a minute. Yeah. So any solution for this issue which we have discussed? Performance issue is the major drawback with synchronized methods, right? So how will you address this issue? Okay.
You need to
Next.
implement a global lock.
we have to implement?
Global lock.
No. So basically here you can address this issue with synchronized blocks. We have synchronized blocks. Okay, synchronized block is actually used to address this issue. Here, what is synchronized block? You see, synchronized block, it helps us to address this issue. How? You will find that in case of synchronized blocks,
You can lock only critical section of code and avoid locking
yeah, so
the
only
whole.
part of the method can be locked. Critical section means, you see, the term critical section is used here. That means mainly the code where we do the updates or modifications to that object. Okay, mainly the code where we make changes to this object. So we want to wrap that code in a synchronized block. So we won't declare this whole method as synchronized. We won't do this. Okay. Instead, only part of this method will declare it as synchronized. Only part of this method will declare it as synchronized. Okay. That is what we do. So if only part of this method is declared as synchronized, so what is the advantage here? You see, instead of holding that object lock for the entire execution of this method, see we say the thread need not acquire the object lock for the entire execution of this method, right? It will hold the object lock only. It will hold the object lock only for the period of time or partially till that synchronized block executes. Till that synchronized block executes, you see, you will find that this method, and you see that lock will be acquired. That's it. Okay. Yes. That is what happens. Fine. Now let me show you how to declare this method asynchronous. Actually, we have only small method here. Okay. If it is a large method, then it will be advantage for us to use the synchronous blocks. In this case, you see, it doesn't make much difference for us, to be frank. Okay, because our methods are very small methods. Yeah. Now you see, I declared it as synchronized here, and add this here. That's it. Okay. Now that means we are creating a synchronized block for this. This means we are referring to which object here? This refers to which object here?
Withdraw method.
Which object? Not methods. I'm talking about objects here. This refers to which object here?
Withdrawal amount.
Object, not method. I'm not talking about object methods. I'm talking about object. This refers to which object? This holds current object reference. What is that
Yeah,
object
yeah,
here?
yeah.
So this refers to that savings account object whose reference is used to call this method. Okay, so basically here uh, in this run method we have the object reference which is used to call this withdraw method. So basically this means we are referring to that savings account object itself. Here that means we have created the synchronized block is for that savings account objects. The synchronized block is for the savings account objects. Okay. So whenever a thread wants to execute the synchronized block, it has to acquire the current object's lock, the savings account object's lock. It has to acquire it. Okay. Yes. I hope you people got it. So this is what we can do here. So anyone got any questions in this regard? Okay, good. Now let's move on. Here, similarly, we have this is a non-static synchronous block. I can say this is a non-static synchronous block. Similarly, you will have static synchronized blocks also. Okay, in the static methods you can add them. You see, I can do this instead of declaring this method as synchronized. What you can do here, you can just use this synchronized block, and you can specify the class name here. So you want the synchronized block for this class. That means if a thread wants to execute this static synchronized block, it has to acquire that class lock. So this is about synchronization. I hope people got this, whatever we discussed here. Anyone got any questions? If not, let's move on. So the next thing which I would like to talk about here is regarding the thread communication. You know what? We can make the threads to communicate with each other, to interact with each other. So how can we make the threads to communicate with each other? You know, why we need we need to make the threads to interact with each other? Let's talk about it. Here, for that, I'll take this example. Producer and consumers. This is an example, a classic example. You know, we have two threads called as producer and consumer. Producer thread consumes, producer thread responsibility is to produce the data. Producer thread's responsibility is to produce the data continuously to produce the data. And consumer's thread responsibility is to consume all the data which is produced by the producer. Consumer thread's responsibility is to consume all the data which is produced by the producer. That is the responsibility of the consumer thread. You know, here these are two never-ending threads. So producer produces the data and the consumer thread consumes the data which is produced by the producer. Okay, yes. Fine. Here, let me just work with this example. Okay, I'll give you a diagram which helps you people to better understand this, what we're talking about. So you see, as I told you people, both the threads will, consumer will consume the data and producer will produce the data. You see, the producer thread, after producing the data, the producer thread, after producing the data, what it does, it will actually store the data into this object called as text. Okay, let's say it is text object here. So let's say we have these two threads. Each thread is represented by an object. You know that threads are also objects in Java. So we have a producer, and we have consumer. So these are the two threads. Now both the threads will be operating on this data. Okay, operating on this object. So what the producer thread does, it will produce the data and it will add this data to that X object. X object is the common object between these two objects. Okay, X object is actually the common object here. Yes. So here producer thread will produce the data, adds it to this X object, and consumer thread will be consuming the data which is added by the producer to this X object. Consumer will read the data from this X object here. That is how it works. So we have to implement this example. Let's see. First of all, I'll define a class here. Okay, let me just create a package called as communication. Let me just add separate these classes here. We'll define a class called as X. Here in this X object, we'll add a variable with the name data. Let's say the data which is produced by the producer is nothing but it is that integer values, numbers. Okay, that is the data which we're talking about here. You see, I will add two methods. One method which reads the data from this object. Okay, it returns the data which is stored in this object. And the other method which assigns the data to this object, you see, this way. Just dot data equal to data. I'll make this method synchronized. Okay, because now both the threads will be operating on the same object, right? Through this methods. So I want to make sure that these two threads basically they don't overlap with each other, causing that issue. So now this is the common object, okay, on which the threads will be operating. Let's define the consumer thread. So I'll make this class extends thread class, or you can just make this class implements runnable you wish. To this consumer thread, the X object reference should be available. Declare that X reference variable here, and I'll add a constructor to pass this X object reference to initialize that X object. Through this constructor, you see, parameterized constructor, the X object reference is supplied to this object here. Yes. Okay. Here, now let's define the task for the thread here in the run method. So what this thread is supposed to do, it is supposed to read that object's data, right? And this thread has to execute continuously, never ending. Okay, yes. I'll do this while true, set it to true. X dot, how the thread will read the data from that object, it uses the get method. Okay, You see, whenever the thread executes this get method, I'll print a message here in the method itself. You see, we'll print the name of the thread, thread dot current thread dot get name. Okay, and we'll also display the data. What data it reads, will display it. That's it. Similarly, here also, I'll just do this. What data it is adding, will display the data. So which thread will execute the get method, producer or consumer? Which thread will execute this method, producer or consumer?
Producer.
Get method, consumer, not producer. Get method is used to read the data from that object, not to assign the data or add the data to the object. Okay. Yes. So now here, let's define. Okay, just go through this consumer thread class. Is it clear for you people what we did here? Any questions in this regard, please let me know. I hope you understood this task, right? Yeah. Similarly, let's create a producer thread here. Let me quickly add a parameterized constructor. Override that run method here to define the task for the thread. So this thread is supposed to produce the data continuously and add it to the object. It has to repeatedly, continuously produce the data and add it to that X object. And through this put method, it does that here. Okay. Now see here, we have these two threads, right? See, because both the threads are operating on the same object through this method get and put, I've made sure that they are synchronized. Okay. Let's start these two threads here. Okay. Test program. Here I'll write it in this package, and we'll instantiate this thread. First, we create X object here, and then create a producer thread object. We pass the X object reference. Name this thread producer thread here. Set name, let's say, is producer. And you see here, we'll instantiate that consumer thread. Consumer thread dot set name consumer. And then see, to both the threads, we are passing the same X object reference here, X class object reference. Okay. Now let's start the threads. Produce a thread dot start consumer thread dot start. That's it. Yeah. So now, see, this is the code which I've written. Let's start these two threads. Okay, I'll stop it. See, they're continuously executing never-ending loop, right? I've stopped it, terminated forcefully in the middle of the execution itself. Now, just a minute. I want you people to observe this output once. Just a minute. Not now. I'll show you. Yeah. All of you check this output and tell me whether everything is working fine or not. Yes. Is it working according to our plans? Is there any issue? Yeah. Come on here. So I'm talking about very important topics. But, I don't see much response from you people. I'm not sure why you have decided to, you know, be silent in this regard. So, what is do you see any issue? Is everything working fine here? What do you think? I can say that there is an issue. If you look at this output, you'll find that the producer thread, sorry, the consumer thread is consuming the same data repeatedly, and producer thread is producing some data. Whatever the data which is produced by the producer, see, I don't see the consumer anywhere in between here. Yes, you got the point. So the issue is here, these two threads, they are not coordinating with each other properly. Whatever the data which is produced by the producer is not consumed by the consumer. They are not in sync. So producer, after producing the data, you see, it is not waiting for the consumer to consume it. It is again producing the new data. Consumer also, when it gets a chance to execute, so what it is doing, it is consuming the same data repeatedly. It is consuming the same data repeatedly here. Yes, it consumes the same data repeatedly. So it's not allowing the producer to produce new data. It's not allowing the producer to produce new data. Okay. Yes, that is the problem here. So these two threads are not collaborating with each other properly. Okay, they are not coordinating with each other properly. That is the problem here. Though you see, we have made these threads to synchronize. You see, these threads are synchronized, but still we have this issue. So what to do? This is where your thread communication comes into picture. So we have to make these threads to collaborate with each other, communicate with each other. You have to make these threads to collaborate with each other, to communicate with each other. Yes. So I hope you people got it. Yes. So is it clear for you people? Now, how to make the threads to collaborate with each other? We'll see that. Definitely we'll see that. Yes. I'll talk about it in the next class. Okay? We'll discuss about it in the next session. Yeah. So I'll stop it here today, but I have a request. People are not responding in the class. It makes the class very bored, and to be frank, it looks like as if I'm only talking to myself. There is no one in the class. So make sure that you communicate. Try to make the session interactive. That is very important. Okay. Yeah. Fine. So in the discussions, you'll get many important points. Uh, that is important. I'll stop it here today. Let's meet tomorrow and we'll continue our discussion. Yeah. Thank you all. Bye bye.